today I'm going to provide you a video lecture instead of live lecture. Now we were learning motion, right? So in motion, as what I told you, that in motion what we saw earlier was distance, displacement, then we saw uniform motion, non-uniform motion, then we saw speed. Okay, now there is a difference between speed and velocity, right? There is a difference between speed and velocity, and what is that? Let me show you. Speed, as what I said, right? Speed, as what I said, is distance travel upon time taken, right? So when you talk about speed, when we talk about speed, speed is, we say, is distance travel upon time taken. But when we talk about velocity, right? When we talk about velocity, it is not exactly the same. It is displacement upon time taken. So understand the difference between these two. But about speed and velocity, speed is what? Distance upon time taken, and velocity is displacement upon time taken. Hence we call this is a scalar quantity. Which one? Speed is a scalar quantity. Okay, so this is a scalar quantity and this is a vector quantity. Why vector? Because displacement is vector, that's why velocity is also vector. Distance is scalar, that's why speed is scalar. Anyways, these both are scalar, right? Here one is scalar, one is vector. If any one quantity is vector, then the whole thing is vector. Now the thing is what? So basically this required only magnitude. So when we talk about speed, if somebody asks you what is, how much speed you are traveling, so you just say one value, 100, 80, 40, right? But when we talk about velocity, it has to mention with a direction also. Okay, so speed is a scalar quantity and velocity is a vector quantity. This is the difference between these two. Then the both SI unit and both formulas are same. If we talk about the formula, right, if we talk about the formula, V is equal to S upon T, this formula is also used for speed. V is equal to S upon T, this also used for velocity. They both are same. Okay, so then we started with speed, velocity. Okay, then we talk about rate of change of velocity. That's what we are talking. Rate of change of velocity is what I told you is an acceleration. If your speed is increasing or decreasing with respect to time, right? If your speed or velocity, right, we have to take velocity here instead of speed, because even acceleration is a vector quantity. So we have to take velocity. Okay, so the time rate of change of velocity or change in velocity with respect to time is called acceleration. You must have heard this word accelerator. Okay, when we talk about accelerator, yeah, you must have heard this word accelerator. So when we say accelerator, what does that mean? Okay, when we say accelerator, what does that mean? Accelerator is what? Which you give in your car or a bike, which will increase or decrease the speed. When you give accelerator, the speed will increase. When you release it, the speed will decrease. So acceleration is what I say. Acceleration is change in velocity, whether it will increase. Change means whether it increase or decrease upon time taken. Okay, now how you are going to represent this? So acceleration is represented by small letter a. Change in velocity. Change in velocity, in physics or chemistry, they used to have this triangle. This triangle gives you a symbol that tells you change upon time taken. So it is t. So when we say change, change is delta. This is called delta. So change in velocity upon time taken. Right now, how can this change? Change is like v minus u. Okay, so what is v? This is final velocity, right? And what is u? That is initial velocity. Okay, that gives you change. Simple. So change is what? Final velocity minus initial velocity upon time taken. That's it. So acceleration is what we say, change in velocity upon time taken. A is equal to delta V upon t. Now you must be wondering what is the unit for the same. So as what I said, A is equal to delta V upon t, right? Or we can also write V minus U upon t. Now what is the SI unit? Now I told you what is SI. SI means System International. System International. Now what does this mean, System International? See, all over whole world they are using different units. So in order to make things in one unique way, they have made SI. SI is System International, which has these three things: MKS. M is meter, K is kilogram, and S is second. So basically, whenever they try to measure length, they used to measure in meter. Whenever they used to measure weight, they used to measure in kg, right? And whenever you used to measure time, it's in second. So whenever we talk about SI unit, right, SI has these three things: MKS, meter, kilogram, second. So now velocity is what? Meter per second, and time is second. So the unit of acceleration is meter per second square. Sometimes they also write it like ms raised to minus 2. Why? The power bill when you take it up. So this is the SI unit. This is the SI unit of acceleration. Let me show you in your textbook. See, during the uniform motion, the velocity, right, of an object remains constant. So, but in non-uniform motion, its velocity increases or decreases, right? That's what we say. Acceleration is what? Change in velocity upon time taken. So A is equal to V minus U upon t. This kind of motion is an accelerated motion. So there are two types of motion. One is accelerated motion and one is retarded motion. Now what is accelerated motion? In accelerated motion, and one is retarded motion. In this, the velocity increases. So basically you are going at 20 km per hour, then your speed increases to 40 km per hour, your speed velocity increases. But in retarded motion, your velocity decreases. In retarded motion, for example, you are going at 100 km per hour and then you apply brake, your speed will slowly increase to 80, 60, 40, 20. So that is the retarded. In both cases, the velocity is changing, but in accelerated motion, your velocity is increasing. In retarded motion, your velocity is decreasing. Okay. So in non-uniform motion, you can see these things, right? So in uniform motion, the velocity increase or decrease will equal. Such acceleration is also called uniform acceleration. So what do you mean by uniform accelerated motion? Uniform accelerated motion is what? Suppose this is 20. So in 1 minute it is 20, 40 in 2 minutes, 60 in 3 minutes. So basically equal time and equal increase in speed. That is called uniform accelerated motion. It is acceleration, but even it is accelerating at an equal interval. In non-uniform acceleration is what? Your speed is increasing, but not in uniform way. Sometimes it is 2, sometimes it is 10, sometimes it is more, sometimes it is less. So it is increasing or decreasing in non-uniform acceleration. Okay, so that's what they are trying to tell you, non-uniform acceleration. Okay, so understand this small thing here, understand this small thing here, what they have told you. Clear? Uniform and non-uniform, accelerated and retarded motion. Okay, so this is quite simple as what you understand. The SI unit, I told you what is SI unit. Velocity, speed. First of all, you should understand the difference between speed and velocity. Second thing, you learn what is acceleration. Third thing what you learn is accelerated motion, retarded motion. In accelerated motion, it has uniform accelerated motion and non-uniform acceleration. Okay, so that is what I am going to teach you so far today. That's it, right? Tomorrow we are going to have a live class and we will learn more regarding graphical representation of motion. Okay, that's it for a day. Thank you so much.